This is a story about a question that seems too large to answer. It is the story of how humans measured the size of the Earth before machines existed, before instruments could look outward from the sky, and before distance could be counted automatically. There were no satellites moving above the clouds, no clocks shared between distant cities, no maps drawn with precise scale, only sunlight, only shadow, only distance remembered by travel and time. For most of human history, the Earth felt flat. The ground beneath the feet offered no sign of curvature. Fields stretched outward until they met the horizon. Roads ran straight until they disappeared from sight. Nothing in daily life suggested that the surface of the world bent, and yet quietly the world gave clues, not quickly, not dramatically, but patiently. Some of the earliest clues appeared at sea. Sailors noticed that ships did not disappear evenly as they traveled away. They vanished in stages. First, the hull slipped from view, then the mast lowered itself behind the horizon. Then finally, the sail faded. If the sea were flat, the ship would shrink evenly. Instead, it seemed to sink. The water itself appeared to curve. On land, the sky offered its own signs. Travelers moving north or south noticed that the stars changed. Some constellations climbed higher, others slowly disappeared below the horizon. The sky was not the same everywhere. During lunar eclipses, another pattern appeared. When Earth passed between the sun and the moon, its shadow crossed the moon's surface. That shadow was always round. It did not stretch. It did not flatten. It did not change shape. A flat object casts different shadows depending on orientation. A sphere does not. Slowly, among careful observers, this idea settled. The Earth was not flat, it was curved. But this realization created a deeper uncertainty. If the Earth curved away beneath the sky, how far did it curve? How large was the world? In the ancient world, distance was known by effort. A day of walking, a week of travel, a month along a river. There were no shared units across regions, no precise timekeeping between cities. Maps existed, but they were symbolic. They showed relationships, not scale. Measuring the size of the entire Earth seemed impossible. And yet, the problem remained. If the Earth had a shape, then that shape had dimensions. Those dimensions were not unreachable. They were hidden in patterns, in angles, in shadows, in the relationship between sky and ground. Someone only needed to notice, and then wait. In the 3rd century BCE, the city of Alexandria stood as a meeting place of ideas. Scrolls arrived from distant lands. Mathematics, geography, astronomy, and poetry were gathered together. At the center of this collection stood its librarian, Eratosthenes. He was not known for invention, but for attention. He read carefully, he listened. One report from the south stayed with him. In a city near the Nile, called Sieni, travelers described a quiet event. On the day of the summer solstice, at noon, the sun stood directly overhead. Vertical objects cast no shadow. Light reached straight down into deep wells. This happened every year. Eratosthenes compared this with Alexandria. On the same day, at the same hour, objects in Alexandria did cast shadows. The sun was bright, but it was not directly overhead. This difference was not dramatic, it was subtle, and that was why it mattered. If the sun were close, its rays would spread outward. If it were distant, they would arrive nearly parallel. Eratosthenes trusted the second explanation. The shadows were not changing because the sun moved differently. They changed because the earth curved beneath it. Rather than argue, he decided to measure. On the solstice, at noon, Eratosthenes placed a vertical rod into the ground, a gnomon. As the sun reached its highest point, the rod cast a shadow. Eratosthenes measured the angle between the rod and that shadow. The angle was small, only a few degrees, but geometry gave it meaning. A full circle contains 360 degrees. This angle represented a fraction of that whole, 1/50th. Eratosthenes paused. If the earth curved evenly, then the distance between Alexandria and Syene must also be 1/50th of the earth's total circumference. The planet had revealed its scale through a shadow no longer than a hand. Eratosthenes did not travel between the two cities himself. He did not need to. The route between Alexandria and Siena was already known. It followed the Nile, a river that had been measured carefully for generations. Egyptian administrators tracked distance for practical reasons, for trade, for taxation, for communication between regions. Caravans moved slowly along familiar paths. Their journeys were counted not in instruments, but in time, repetition, and experience. The distance between the two cities was recorded as about 5,000 stadia. This number had weight. It was not a guess. It was a remembered distance, tested again and again by travel. Eratosthenes took this known distance and returned to his earlier observation. The angle of the shadow in Alexandria was 1/50th of a full circle. If that angle represented one small arc of Earth's surface, then the distance between the two cities represented one small portion of the planet itself. Eratosthenes multiplied the distance by 50. The result was the circumference of the Earth. Not an abstract idea, not a symbolic number, a measurement. Later records suggest he refined the number slightly, adjusting it so that Earth's circumference could be divided evenly into degrees. Whether this refinement was his own or the work of later scholars is uncertain. What matters is the outcome. When translated into modern units, his estimate falls remarkably close to the true value. Within a few percent, the Earth had been measured without walking its edges, without seeing it from above, and without technology. Only a shadow, only distance remembered by travel, only patience and thought. There was no announcement, no public celebration followed the calculation. Eratosthenes did not mark the moment with ceremony or monument. His result simply became part of knowledge, copied into scrolls, referenced by later scholars, sometimes misunderstood, sometimes ignored. Centuries passed, empires rose and fell, libraries were lost, languages changed, yet the method endured. Across different cultures and eras, scholars continued to measure the Earth, using the same quiet logic. Angles revealed curvature, distance revealed scale. Shadows were replaced by stars. Simple rods were replaced by instruments. But the reasoning did not change. The Earth could be measured without touching its edges. When modern technology finally confirmed Earth's size, it did not overturn this ancient measurement. It agreed with it. The sun still casts shadows. Angles still matter. The earth still curves beneath the sky. Before technology, humans measured the world by watching carefully, waiting patiently, and thinking slowly, and that was enough. After the measurement was made, nothing about the earth changed. The ground did not feel different beneath the feet. The sky did not appear closer. The horizon did not curve more clearly. Life continued as it always had. People walked familiar paths. Ships followed known routes. Seasons arrived and passed in their usual rhythm. And yet something subtle had shifted. The earth was no longer only experienced. It had been understood, not fully, not perfectly, but enough. Enough to know that the world beneath the sky had shape, scale, and quiet consistency. The measurement itself did not require motion. It did not require travel across oceans or journeys to the edge of the land. It required waiting for the sun to rise to its highest point, waiting for a shadow to fall, waiting long enough to notice that the shadow was not the same everywhere. This kind of waiting is easy to overlook. It produces no sound, no spectacle, no urgency, but it reveals patterns that do not change quickly, patterns that remain even when no one is watching. The earth continues to turn, the sun continues to cast shadows, angles continue to form quietly on the ground. Every day, the same measurement is possible, not because the method is repeated, but because the world remains consistent. The size of the earth does not need to be announced. It does not need to be proven again. It exists in the distance between places, in the way light falls differently across the land, in the slow change of the sky as one moves north or south. Long after the original measurement, long after the details were written down, the earth continued exactly as before, silent, stable, measured. And as time passed, new tools appeared, new instruments, new ways of looking outward. But the earliest understanding remained valid. The world did not grow larger. It did not grow smaller. It simply revealed what had always been there. A planet that could be known without being touched, understood without being seen from above. Measured not by force, but by attention. And that attention did not end. It continues quietly, wherever sunlight meets the ground and a shadow forms without effort. The measurement of the earth did not belong to a single moment. It did not depend on one place or one observer or one perfect day. The sun continues to rise. It continues to reach its highest point. It continues to cast shadows everywhere. In one place, a shadow falls short. In another, it stretches farther across the ground. The difference is quiet. It is easy to miss. The ground does not draw attention to this difference. It does not announce what it reveals. It simply receives the light. If someone waits long enough, the same pattern appears again, not because it is repeated, but because it never stopped. The earth does not need to be measured again to remain measurable. Its size does not depend on memory. It does not depend on writing or record. It exists whether or not anyone notices. The distance between places remains steady. The curve beneath the horizon does not change. Only attention changes. And when attention slows, the same understanding becomes visible once more. Time moved on after the measurement. Years passed, then decades, then centuries. Cities changed, roads shifted, languages transformed. Some names were remembered, others faded. But the earth remained. Rivers continued to follow their paths. Shadows continued to fall at different angles. The sky continued to change slowly with distance. People traveled without knowing the exact size of the world. They lived without needing the number. The measurement did not alter daily life. Fields were still worked. Ships still crossed the sea. Seasons still arrived in their time. What changed was quieter than that. The world had been placed into proportion, not as a mystery, but as something that could be understood without being controlled. The earth did not become smaller, it became clearer, and clarity does not rush. It settles slowly, like light spreading across the ground at sunrise. The earth itself does not hurry. It turns at a steady pace. It follows the same path again and again. Day becomes night. Night becomes day. Shadows lengthen. Shadows disappear. Nothing in this movement demands speed. The early measurement of the earth followed the same rhythm. It waited for the right moment. It observed what was already happening. It trusted consistency. This way of understanding the world does not belong only to the past. It still exists wherever patience exists, wherever someone notices the way light behaves, wherever distance is felt rather than calculated, wherever time is allowed to pass without interruption. The earth continues quietly, not as a problem to be solved again, but as a presence that does not change its rules. Measured once, confirmed many times, never in a hurry. The sun still rises, shadows still form, angles still appear on the ground without effort. And as long as this continues, the size of the earth remains quietly known, not announced, not repeated loudly, simply present.